There's a few requirements for a matrix to be invertible. So basically, it needs to be square, so n by n. And if you augment it with the identity, it needs to have a solution. Okay, now, if you have an inverse, if you multiply times, if you right multiply or left multiply, you will get just the identity matrix. Kind of like when you multiply 2 times a half, they cancel, leaving you with the identity, which is a 1. Same thing here, except you get the identity matrix of size, or of dimension n. Now, there is a formula you can use. Basically, if you take this general equation right here, A is a matrix times x, where x is a column of variables, equal to b, which is the constant terms. So this is like, I don't know, let me see, let me get a pen here. So basically, if you have a matrix, call this your A. There's some numbers here, who cares? We're choosing a 2 by 2 times your x1, x2, so your x and y are your 2 dimensions, equal to some constant 1, 3, what? So this is my b, this is my x, and there's the a. So the idea is, if I multiply both sides by A inverse, I'll solve for x. So if I do, if I take this equation and take, well, so if A inverse exists and I multiply times A, oops, this would cancel, it should give me an I. This is a vector. So this right here is a solution to x. So x is equal to A inverse B. So if you find the inverse, multiply times B, you can get x. Now, if you were to multiply this out, right? This is technically saying 1x1 plus, is that over? 1 times x1, right? If you were to multiply this out, it would be 1x1 plus 2x2 equal to 1. So that's what this piece right here is technically creating. Then you have 3x1 plus 4x2 equal to 3. So this system of equation can be turned into a matrix equation. So the coefficient matrix is right there, right? The 1, 2, 3, 4. 1, 2, 3, 4. The variables are right here, x1, x2, or you can use x and y or x, y, z equal to this. So this is the same as we were doing last time, right? 1, 2, 3, 4. So instead of having an augmented matrix, right, you have a matrix equation. So we can either solve this matrix to get x1 and x2, or you can punch this into the calculator to find x1, x2, or but you would have to find A inverse first. that make sense? Like what they're talking about, where this came from, this formula? So basically, they're rewriting your system of equations as a matrix equation. That's all we're doing. Because if you multiply these two matrices, you'd get it back to here. You multiply this out. There's just another way to think about it. So this formula basically says, if you were to solve it in general, you can create your own formula. So if you have the a part, which is this part, if you find the inverse of this, multiplying times the b part, which is this, you will get the answer automatically. Instead of doing the row reduction or the it's called the REF from the calculator, you could do that instead. That's all we're saying. Oh, you can, of course, you can do it by hand and whatnot, but we're not going to. Over here, they want you to verify that it is an inverse. And in order to do so, you have to remember that let me phrase it better. So if a times b is equal to I, and b times a is equal to I, then a and b are inverses of each other. All right. So all you got to do is multiply them. Of course, this is a dimension 2, so this is assuming n by n size. So a and b are n by n. So here, if I multiply these two out and this out, they both have to give me the identity. So I need to get 1, 0, 0, 1, and then again the same thing. This right here is the identity matrix. So let's try to do it on the calculator real quick. Yeah, two matrix multiplication, we have two 2x2s. First matrix was 2, 1, 7, 4. the other matrix is 4, -1, -7, 2. -4, -1. 4, -1. -7, 2. So here's doing what did I mess up? 2, 1, 7, 4. 4, -1. Oh, I see. It's supposed to be 4, -1, -7, 2. Oh, I see. +4. As you can see, the calculation gives me the identity matrix. You just need to multiply it again the other direction. Okay, so now if I do it on the calculator here. The matrices were. All right. 2, 1, 7, 4. So go to the second matrix. Edit. Make a 2 by 2. Oops, that's too big. 1, 7. All right, so quit once you saved it. Go back into the matrix menu, edit B. And 2 by 2. 4. -1. -1, -7, 2. 4, -1, -7, 2. All right, so there we go. Once they're in there, multiply them like this. You should get the identity. So then try it again, but make sure it's the other direction. So go back in the menu. Big B. You can put the time symbol if you want. An A. So if A times B and B times A equal the identity, so these are both 2 by 2 matrices. If I get 2 by 2 identity matrices in both directions, then it is an inverse. So what they want to see here is, excuse me, that the result is going to be this. Right here in the middle, they're doing the product. So the way you multiply matrices by hand is using here. Is using just a pattern. You do row times a column. And then this row again times that column. Then you do this row times this column. This row times that column. It's kind of tedious. I don't really want you to do it that way, but just so you can see at least once. This row times this row would be 2 times 4, which is 8. 1 times -7, right? Is -7. So that came from. Then again, you do this one. 2 times -1 is -2. So these two. 1 times 2 gives me 2. So you finish that row. Then you cycle 7 and 4 through both of these. So 7 times 4 is 28. 4 times -7 is -28. 7 times -1 is this. 4 times 2 is 8. So what they showed up here, the A times B, the solution will be here. So row 1 times column of B, first column of B is right here. So 2 times 4 plus 1 times -7. See what I'm saying? So it's going to be this guy times this guy. So 2 times 4, 1 times -7. That result is going to be the upper left of the matrix. Then you do the same row times this one. That's going to be down here. Be 2 times -1 plus 1 times 2. But I don't really want you to do it by hand, but that is the pattern, that's the algorithm. Oh, excuse me. Now, inverse, to find an inverse of a matrix, you can just use one button on the calculator to do it, or you can do it the long way. That's to augment the original matrix. With the identity. So if you solve this one, either by hand or the row reduced echelon form on the calculator, use RREF. And you'll get your, you will get your identity over here. And then over here, you'll have A inverse when you solve this, when you finish working it out. That's one method to find A inverse. So you solve this guy. Okay. So let me show you both. All right, so if you put in the matrix A, and then go back in there and press enter under names to call it out. Oops. Excuse me. So input A, call it out, and then just press the inverse button. It should find it for you. So this is A inverse. Another way to solve it, or do this, is to go in there, make it a 2x4, and put the identity over here. Then solve that guy. So see how the solution over here is A inverse. That's what I mean. You solve that version of A to get that. You can also use a solver. There's many different ones. Just type in the dimension, which is a 2x2. And then just tell it to do inverse. So 4172. 4172. There's the inverse we found. You can do row operations and eventually get there if you want to, but that can take a couple of pages. And I don't want to make you guys do that unless you want to. That's your call. Up to you. There's another way to find an inverse, is using this formula. I think this is the easiest way to do it on paper, but it only works for 2x2s. So having this matrix, just remember that this is my A, B, C, D. You can use this formula. So let's go ahead and do that guy real quick. One second. No, Okay. This is what the formula is saying. Basically, this is my. A, B, C, D. So A inverse would be equal to 1 over AD minus BC. So this is 2, 5 minus BC. So it'll be 3 times -1 times D, which is 5. Negative B, so -3. Negative C, so that's in the same spot, it just becomes positive. And A, 2. Multiply this matrix times this, what's it called? Scalar. That would be 10 minus -3. Remember how, you guys remember how you multiply scalars, right? So all you gotta do is multiply every single number times 1 over 13, you'll get this right here. When they write it this way, they're basically saying 5/13, -3/13, 1/13, 2/13. But again, I would just use a solver and be done with it. Okay. Any questions on these ideas so far? Is that all right? That makes sense? So on 10 and 11, just use your formula, or you use whatever you want. I'm not going to tell you what to do. 12, they're just looking for the solution, so use any of the methods we've talked about. You could do elimination, substitution, you could just punch it into a matrix solver. Up to you. Any questions about those ideas? And you're not all matrices have inverses. If you looked at the notes, it's not guaranteed to exist. Okay, let's move on then. 10.4. This notation right here, you say that's like looks like an absolute value. When you see that on a matrix, they're asking you to find the determinant. They can also write it as det parentheses a. This is asking for the determinant of a. And only square matrices are gonna have determinants. Okay. And determinant is no big deal. You can, there's also functions on your calculator and online, of course. Just like one button, but the formula is pretty easy. If you're gonna do it by hand, let's call this A. So the determinant of A is equal to, well, you know what? Let me give you the formula. If you have a general 2x2 with A, B, C, D, the determinant is A, D minus B, C. So that'll be 4 times 9 minus B times C. So you get 36 minus 14, which is 22. That's all you got to do. But there is a determinant button on your calculator. Looks just like this. I think almost every the TI 30 and 34 and 35. That's right. 30 TI 30 and the 83, 84 all have it. It's just this formula. That make any questions on using the formula? They'll be the same for 3 and 4. Okay. I assume you guys are good. All the same deal. Here is a property that I believe it's a formula that says, let me see how I should phrase it. If the determinant of A is equal to, let's call it, I don't know. Say lowercase a. And the determinant of B is equal to lowercase b, then the determinant of A times B, this would be A times B. So -2 times -4 gives you the 8. So all you gotta do is find each one separate. And then this one just be a product. They do want you to multiply the matrices technically. That's what this is right here. But you can use you can multiply them row by column if you like, or you can do the use any kind of technology. But that's pretty much it. The same will apply to here. The only thing is finding the determinant of a 3x3 is a lot of work. I do not recommend doing this one by hand. But you can. It's up to you. But the idea is the same, it's just three-dimensional, but once you leave two, you can no longer do that simple formula. You guys have any questions on 7 or 8? Does that seem okay, or any concerns or issues? Okay. That should be a really quick section. Okay, this is our last section of the whole class, final section. Applications of the determinant. Okay. I can turn it on, I just need to test it. But you know what, for test. What test is that, 4 or 5? Steven? Let me see. Yeah, I don't think there is no test on the matrix stuff, it's just homework assignments. I don't see a test. Oh, wait, I lied, I'm sorry. So for this one, I will not have respondus on, okay? Use whatever you want to solve this guy. No work required for this exam. So I'll just make sure to turn that off. Let's see here. Yeah, moment. Before I forget, let me do it right now. Before this last section is the same stuff, honestly, 10.5. The only thing they're doing is they're using this different method to solve for X and Y. So you're still solving it for the system. They're just using a different method. So you can use any method you want. It doesn't really matter. That question looks, well, it's not a big deal, but it is kind of cool what they're using it for. The work is the same. You guys see that this is just a simple matrix, right? It looks intimidating, but they created the current equations for you. They're saying, okay, well, this circuit has this current going on, this one has this one, etc. So if you just change it to a matrix, you would have 4, 0, 8. Hold on a second. Need to make it bigger. So that's all this is, right? Same deal. They're just using current 1, current 2, current 3. So you're trying to figure out what is the 3 currents. what is x1, y, x1, x2, x3? Or xyz, all the same. You see what I'm talking about? Like, here they have a pulley system, which is really neat. They create three systems of equation to figure out the tension. So what is the tension on 1 and 2? Well, thankfully this is not a physics class, so we don't have to, I'm not going to force you to create the system. System's already made, which is great. So just solve it. Solve the system using any method. The only thing I want you to see is how useful matrices are. They can solve all kinds of applications and optimization problems. And you can use many different methods to solve the system of equations or the matrix. Does that make sense? That's the only thing I really want you to get out of 10.5. Actually, every time you do a Google search, it's solving a very complex system of equations with like, million by million rows and columns. And the solution turns out to be what you're searching, your query. So something that's always being used in the background, that's the most used topic outside of mathematics, and it's going to be linear algebra. That's basically what this is, matrix theory. Anyway, you guys have any questions about anything in general? Okay. Yeah, that's pretty much it. Just we're not gonna have any classes. I guess this will be the final class. So yeah, let me know if you need anything. We can meet up or meet up during class or at any other time, doesn't matter. Just let me know. I'll be grading your exams very soon. I think I'm a little behind because I gave you guys some extra time because I can't start until you're done. So hopefully we'll get that done pretty quick. But if you have any issues, any technical problems, let me know right away because we don't have much time left. So don't be scared to reach out and try to meet with me to work on stuff. Okay. Let me take roll.